This video will cover an introduction to workflows with DAGman, the workflow tool that's integrated with the HTCondor scheduler. As a note, these slides and the original presentation of them was given by Lauren Michael at HTCondor Week 2020, and this video is being recorded later by myself, Christina Cook. Okay, so what we're going to cover today is sort of a brief intro to workflows, why create them, how can we think of workflows as a DAG or directed acyclic graph, and what does that mean, and what tool in Condor, DAGman, can help us execute workflows described this way. We'll look at some examples of workflows implemented and executed using DAGman, and then talk about some of the ways that DAG workflows can be customized, focusing on node level options and modular organization. But there's lots of options and ways to customize DAG workflows, so we won't cover everything, but there will be a link to these original presentation slides which have extra information that you can look at for more details. So as a side note, this presentation also assumes that you are somewhat familiar with HTCondor and have submitted Condor jobs using Condor submit files, as that will be relevant in some of the later examples. Okay, so first, briefly, why would we want to use DAGman or a workflow tool? Typically, it's because we want to automate a process that has multiple steps that need to be run in a particular order. And we want to do this without submitting one and then waiting for it and then manually submitting the next step and so on. This is especially true if we want to run that workflow multiple times. We'll be thinking about workflows as a DAG, or directed acyclic graph. So this is an ordering of vertices, also called nodes, which is the term we'll be using through the rest of the presentation. And their ordering is established by directed connections between them called edges. And so acyclic means that there's sort of a beginning and the end, and this isn't an infinite loop or cycle. But as you'll see later, it doesn't have to be strictly acyclic. There are ways to generate cyclic loop-like structures in DAGman specifically. Okay, so this is how we're going to think about describing workflows in this directed acyclic graph. Condor's DAGman tool is meant to take the representation of the workflow as a DAG and run it as a set of Condor jobs. And so DAGman, again, is the tool that does this. And you can see the link to the manual page at the bottom here, where a lot of this presentation is coming from and where you can also go for further reading. All right, so in the beginning part of this presentation, we're going to use a sample workflow like the one on the right, where we are assuming we have some kind of step that splits a large input that is then processed as a bunch of individual jobs in the middle section, and then at the end, once all those jobs have completed, we're combining them. And so each of the colored boxes represents a job, which is going to be a node in the DAG, and the arrows showing sort of what order things run in are our edges. And so we need our DAG input file to communicate the nodes, the boxes, and the edges, arrows, of the DAG. As a side note, just for space reasons, in the examples you'll see in this presentation, we'll limit that middle step to 3 individual processes or jobs, but it could, range and be as large as you like. But for simplicity, we'll use 3. All right, so here we are at last. Here is a sample DAGman DAG file. We often label these files .dag just so it's clear that that's what they are. And you can see that the nodes of our DAG on the right, the boxes, have been represented using this job keyword on the left. And so the format there is job indicates a node in the DAG. It corresponds to a Condor job, and the submit file for that Condor job is what you see as the last item on the line. And then the letters and numbers in the middle serve as an identifier for that node so that we can refer to it later in the DAG. And you see this in the last 2 lines, the parent-child statements. So these lines are what establish the edges of a DAG. And so you can see that A is the parent to B1, 2, and 3. Similarly, B1, 2, and 3 are the parents to C. And so this is part of why we have those labels in the job lines so that we can establish these relationships in the parent-child lines later. Okay, those labels, the node names, A, B1, B2, and so on, could be anything. So obviously this is a simple example, so we picked things that were simple and easy to identify, but they could be anything. Something meaningful to your workflow is a good idea. And it just happens that the name of the submit file that submits the job for that node happens to match the node name, but that doesn't have to be the case. They could have different names. So those are the main components of a DAG. Those are the pieces that you really need. From those different components, you can combine them together to cook up a huge variety of DAGs representing all kinds of workflows. So as you see here, workflows can have a lot of shapes and sizes, but as long as you can define each node using that job keyword and relationships, each of the arrows or edges using a parent-child statement, you could represent each of these pictures using what we've already discussed. As a side note, sometimes people use DAGs for work that's not strictly sequential or connected. So sometimes a DAG is just a list of jobs with no parent-child relationships, what we call a bag of jobs. Or you might run the same exact workflow twice, but there's no dependency between the two. That's fine. You just don't include parent-child statements for the edges that aren't there. All right, so I think this is the main thing to take away, is these job keywords that represent the nodes of a DAG, the parent-child statements representing the edges, and this will get you probably, hopefully, 90% of the way there to the workflow that you want to execute. So now, how do you actually submit one of these? That's what we'll talk about next. Submission of a DAG is very similar to submitting a normal Condor job. The command is condor submit, and then with DAG tacked on the end, and you'll submit the DAG file, not the submit files. You'll submit the DAG file, which will in turn submit the different submit files representing nodes in the DAG. So let's dig into what that looks like a little bit. When you submit your DAG, what happens first is Condor creates a DAGman job that's going to run in the queue over the lifetime of the workflow. And you can really only see it if you run Condor queue with this no batch option, as shown in the second prompt there. And the command will always be Condor DAGman. So Condor does this automatically. And then in 1 or 2 seconds, however long it takes to get going, the DAGman job will submit the first node, the job representing the first node in the DAG, which for us is node A from our example. And so you'll see this in the queue output. There will be one idle job, and that will hopefully go to running. And then once it completes and moves to the done column, the next 3 jobs will be submitted to the queue, and you'll be able to see them in their idle state before they start running. They will hopefully cycle through similarly. And when they complete, the final job representing node C, or represented by node C, will be submitted as well. Once all of the jobs from the workflow have completed, or there's been a failure, which we'll talk about in a minute, then the Condor DAGman job will wrap up, and then there won't be anything left in the queue. So when you submit a DAG, there's going to be a lot of files that are automatically generated as part of running it. There's going to be a condor.sub file, dagman.log file, lib.error_and_out file. Those all capture information about the DAGman job itself. The dagman.out file, the second option here, has detailed logging about what's happening. And so this is the primary file that we would recommend to use for troubleshooting. It can be quite dense. There's a lot of information, but kind of scanning through it usually indicates what's happening, what might have gone wrong if something has failed. Besides these files, there's also some DAGman metrics files, dagman.log. I think dagman.out here is the same as the one I was just describing. So yeah, there'll be a lot of these files. Most of them you shouldn't need. The first one to go to if you have questions about what's happening is the dagman.out file. Okay, so suppose you've submitted your DAG, but you realize you made a mistake or you want to make changes or whatever, it needs to be removed. The way to remove a DAG is to remove that parent job, the parent Condor DAGman job. If you remove that, all of the jobs that it has submitted or is managing as part of the workflow will also be removed. If you do this, there will be a rescue file created so that in theory you could resubmit and not have to repeat pieces that already completed. So more automated files will appear in your directory if that's the case. Okay, so maybe you don't remove something from the queue, but a job fails for some reason. So if a node job fails, DAGman doesn't shut down right away. It will let things that are already running keep running until it can't make any more progress. So in the example at the right, if our second B job fails, our DAG will keep running as far as it can, which is to finish all the other B jobs, and then it will exit after all of those are completed, and it would be supposed to move on to C, but can't because B2 has failed. So note that it is possible in a job node or in a node in the DAG to submit multiple jobs. For example, B1 the node could be a submit file that submits, say, 10 jobs. There's a bit of risk in doing this because if one of those 10 jobs fails, the whole node B1 will be removed, no matter what the status of the other jobs are. B2 and B3 will be fine because they were submitted separately as separate nodes, separate submit files. But jobs that are submitted all from the same submit file are considered one node. If one of them fails, they all fail. And there's no way to only rerun the ones that haven't finished yet. So we do recommend that if you're setting up workflows in this way, that each node is submits one job, not multiple jobs. Last slide on what can go wrong. The individual jobs can go on hold, just as with any job that's submitted to the queue. Holds aren't interpreted as failures. So held jobs will stay in the queue in a held state until they're removed or released with the issue being addressed. So you can troubleshoot what's gone wrong following the instructions here. You can use condor q minus hold to see the reason, and then fix and release, or remove and do other fixes. In this example, if you don't do anything, nothing will change. DAGman won't stop running, but it won't be able to make progress either. So this is a good thing to keep an eye out for. All right, so that covers the basics of DAGs, the how to describe nodes, edges, submit jobs, and do some basic troubleshooting. So now we want to dig into some of the customizations you can make to create more complex workflows. We're going to start with options that change the behavior of individual nodes or things on the node level. So the first is organization of the individual jobs that are being submitted. By default, the files listed in the job lines here, the submit files, are relative to the main DAG submission directory. But if you wanted to, say, split up the nodes so that they're in different directories, you can easily do this. There's an option called dir that you can add at the end of the job line with the name of a directory. And when DAGman submits the jobs for that node, it will try to find the listed submit file in the directory given. And you can see what that structure would look like on the right, where the individual submit files have been placed in the appropriately lettered directory. So another node level modification that's really useful is the ability to run pre-scripts and post-scripts. So these are scripts that run not on the main execution servers of the system, but on whatever submit point you're using. So they should not be super resource intensive. They should be, usually they're things like checking to see if files exist or checking the output of a particular file, maybe concatenating a couple files together. And so you can see here the keywords to use these are script post and script pre, and the label or the node name that you want to run either after or before. So this example has a postscript running after the A node and a prescript running before the C node. And this is simply you use the keywords, indicate the node name, and then the name of the script that you want to run. And you can, I think you can include arguments as well. Note that just like the submit files are relative to the dir, if you use the dir keyword, the scripts will be expected to be in that directory as well. And finally, the last node level modifier we're going to talk about is retries. So you can use the keyword retry, and again, provide a node name so you know which node to retry, and then the number of times you want to retry. And what this will do is if the indicated node or the postscript of the indicated node, if there is one, returns a non-zero exit code indicating a failure, it will try to run the node again up to the indicated number. So this should only be implemented after you've done enough testing that you're pretty sure everything works. So not so good if you're still trying to make a particular job work, because it may just fail every time. But if in general things are succeeding and you're having transient failures, this can be really useful to keep things moving along without having to resubmit the DAG or manually retry things. There's also a submit file option that does retries, which you could also use instead. And there's more information in the manual links here. Okay, the other main type of customization we want to talk about is how to actually organize and write DAG files in a more modular way. So this is relevant just because often DAGs will have repeated components. So here in this picture, you can see the diamond kind of shape is repeated 3 times. So we want to have an easy way to describe that, for example, or just describe any repeated or large piece of a workflow. So we're going to start with reducing the number of submit files we need. So in our original example, we had unique submit files for each of our B steps. We had b1.sub, b2.sub, b3.sub. But if we write a single submit file shown on the bottom right, b.sub, with a Condor variable represented by the dollar parentheses, we can fill in the appropriate value, for example, which data file we want to use or which directory to submit from, via the VARS option in the DAG file. So you see that on the left. And so each job is going to use the same submit file, but the data variable is going to be filled in when the job is submitted by this VARS line, which is different for each job. So there's still, you have to write out the different VARS lines, but instead of having 3 submit files, you can use just 1. And so here the VARS line is passing a value for the data variable and for the opt variable into this particular submit file. So this next slide talks about how to organize the DAG itself. So we, in our example, have been talking about just 3 jobs in this middle step, B1 to B3, because it's simpler to write. But maybe you have 100 or 1,000 or even 5,000 jobs in that step, and your DAG would be super, super, super long, and the parent-child statements would get really unwieldy. So what you can do is basically separate out that middle step into its own file, what we're calling here b.spl, short for splice, and then reference that file in the main actual DAG file using the SPLICE keyword in the same node name. So this is purely organizational. When you submit my.dag, it will read in b.splice as part of reading in the whole DAG. It sort of concatenates the 2 files together. But this is easier to kind of organize and read for humans. But one limitation here is that you need to know all of the files in advance, or you need to know all the nodes of your DAG, in advance. But sometimes you might not know all the DAG components ahead of time. So for example, that middle step may depend on whatever happens in part A, node A. So a splice won't work because it would change, and that would be too late. So there's another way to separate out steps of a DAG, and that's using what's called a SUBDAG. So in some ways this looks very similar. We have a separate file with all of our B jobs, and it's being referenced in our main DAG file. But the keyword here, SUBDAG external, indicates that instead of reading in the b.dag file at the beginning, it's only going to try to read it in once it gets to that step, once A has finished. In fact, it won't even care if b.dag exists until it's time for it to run. So that means we can write b.dag as part of step A, or after node A, to be whatever we need it to be, and so there's some flexibility there. Note that just like the main DAG will have its own DAGman job in the queue, so will SUBDAG. So you don't want to run too many of these at once. You use them sparingly if you can. One of the other interesting things you can do with the SUBDAG setup like this is you can have components that are cyclic, where if you have a postscript running after a SUBDAG external node, it can evaluate the results of node B, decide whether it needs to be repeated to maybe achieve some kind of stopping condition or not, regenerate the DAG, the SUBDAG, and the retry can be triggered to run that step again. And that can be done until you meet some kind of stopping condition, as long as it happens before the 100th retry. So this is one of the ways that you can kind of hack through the DAGman language to achieve a kind of cyclic workflow, even though technically this is an acyclic graph. Okay, so that's all for the main set of slides and what we're going to cover in this video. There's a ton of information in the HTCondor manual, so go check out the page shown on the screen here. We also will link these slides, they're on the HTCondor Week 2020 website. For more details, just as a quick taste of what's covered in them, there's just more customizations of the two things we've already talked about, node level options or how to organize DAG components. And then there's also information about how to control how the DAG runs kind of at the workflow level, and just some other additional features. So go check out those slides, check out the manual if you have more questions about running workflows with DAGman.